In this semester, we will be together for a course which has been renamed. We call it Advanced System Modeling, and what we will talk is basically we will go over how we can use algebra in a more practical form as scientists and engineers need to use it. This is a very highly recommended course for graduate students, especially if you have some interest in order to read some research papers and have better understanding of that. I'm expecting that by the end of the course you will be able to have some critical point of view and analytical point of view regarding to the problems that you are solving if you have the background of science and engineering. Okay? So the book that we will follow is this book. It's called Matrix Analysis for Scientists and Engineers. It's available in the library, but you can also get it. It's a very good reference book, which I highly recommend you to have it. It is very, as you can see, it's very concise, and this is very good. It's very abstract. It tells you all the required information. Maybe for a week or two, we will quickly revise the general things that you might remember from algebra. So it might be things that you know, and then we will start to talk about the new stuff. All right? The way that we will evaluate you is in this form. We will have 2 examinations, one midterm, one final. We will have homeworks, which at the end of the chapters I will assign you some of the questions which are at the end of the chapter and you need to solve it. And then after that, what else do we have? And we have a course project, which we will talk about it in a month or 2. And because the number of students is not too much, the course project will be an individual project. Okay? Now, about the homeworks, because you might not have the book, or let's say there's a few of you will get the book from the library and there is not much of the book. So what I do, I just scan the questions and I also upload the questions in the module. Okay? I am not so sure if the module of this course is activated yet. If not, I will do it today. If yes, you can register yourself to the module. I am recording the course and I will put them in the YouTube and provide the link to you through the module. In other words, if you are missing any class, you can catch it up. But there is no guarantee that I will be able to do it every day. Like past experience showed that there have been some lectures which I forget to bring the camera, or the camera is occupied by some other task, so I cannot record it. But I will try to record as much as it is possible. And you can always come to me and ask questions if you have any problem. I am Shah, and my office is in Institute of Technology in room 112. My email is shb@icb.tweet.ut.ee, or you can send me an email at shb@ut.ee. Okay? You can come to my office at any point and we can discuss questions that you have, but I recommend you to send me an email and book a time so I will make sure that I will be available in my office at that time. All right? So, let's start by talking about some revisions of linear algebra, a few definitions. Yeah.
How does this course differ from the linear algebra course?
Did you took that course?
Yeah.
Yeah, okay, then you should drop this course.
Okay, so it's basically the same.
Yeah, because they said that we have to rename the course.
Okay. Mm-hmm.
So that was one thing that I wanted to tell you. Okay. But I saw that you just passed the class. I said, okay, then you have already understood.
Oh, okay, yeah.
But that's okay. So let's revise a few things about algebra. Okay, and by first thing we will define a vector. What is a vector? Do you remember what's the definition of a vector?
Magnitude and direction.
It's a sequence of numbers, basically. It's a sequence of numbers. Sequence of numbers with size 1 by n or n by 1. If it is 1 by n, do you know what is the name of this type of vector?
A row vector.
It's a row vector. And if it is n by 1,
Column vector.
it's a column vector. Okay? In this course, when we say vector, we mean column vector. So we are using the term vector and we mean column vector. And it is x belongs to real numbers R. N means that x is a vector which has these elements. And the row vector is represented as X transpose. We remember that what the transpose is. We are just exchanging the rows and columns. The definition of the vector that you provide is a correct definition, but it's the definition that we use in physics rather than in mathematics. So, if I want to have a row vector, I am representing it with the transpose. If I use x and I say that x, y, z, whatever is a vector, it means that by default it is a column vector. Now, if the sequence of the numbers, if the sequence of numbers has size of m by n, we call it, what do we call it?
Matrix.
A matrix. For example, A can be a matrix of real numbers with the size of m by n. So, clearly, if x and y belongs to Rn, then what can we say about x transpose y?
Dot product.
So it is a scalar, which means it's a number, because this will be 1 by n, this is n by 1, the multiplication is 1 by 1. And x, y transpose is a matrix. a square matrix, the size n by n, right? This is a very famous way of making a matrix because we will talk about the rank of this matrix within this course and so on. So let's go over a few notations which we need to know regarding to the matrices and vectors. So what is Rn? What is Rn?
Vector of 1 by n.
Yeah, it's a column vector which elements are real number. R representing real numbers. I will represent it as the set of n-tuples of real numbers represented as a column vector. What about the Cn?
Elements for complex numbers.
It's the set of n-tuples of complex numbers is representing a column vector, right? And what about Rn? This is the set of real valued numbers forming an m by n matrix. And the C m by n is the set of complex valued number forming a matrix of m by n, right? There are two more notations which we will discuss about them, but we will talk about their details, way of calculating them and so on within this course, but we just want to know the notations, which is very useful. The first one is R m by n with subscript r, and C m by n with subscript r. Do you remember this one? This is again the set of real value numbers forming an m by n matrix with rank R. What is a rank? How we calculate a rank? It's something that we will discuss about it in 2 weeks' time with high probability. And it's a very, very important and essential thing. Just quickly speaking, rank tells us how many rows or how many columns of a matrix are independent. In other words, it helps us in order to find out what is the null space of a vector space that we have. This is very essential, especially in computer science, in computer engineering, in the sense that we are having huge data. And we know that there are lots of redundancy inside this data. So calculation of the rank, finding out how many of these data are essential is very important because it helps us in order to compress it. It helps us in order to represent the huge set with less sets of numbers. Imagine that you have lots of vectors representing the movements of your robots. Now you have to find the basis of these vectors so that other things can be calculated by linear combination of them, right? And very famously we said that we can calculate a matrix by this. Is it the result of this one? Is a matrix of n by n, right? Do you know what is the rank of this matrix? The rank will be 1. This is that's why it's very well known. But again, we will talk about this one. We will calculate it and we find out why this number. Okay. Now, what about the C n by n? It's subscript of R. Again, it's the set of complex valued number forming n by n by matrix with the rank R. Okay, with the rank R. Now, many of the examples that we will solve, we will deal with the real numbers, but in this course you will encounter with the things which are complex. In the reality, if you are a graduate student, you actually face with the complex numbers, or in the papers that are represented with the complex numbers. Because if you describe things as a complex form, real, you know that is a subset of, real number is a subset of complex numbers. Now, do you remember complex numbers? Yes? You know, complex numbers usually we are showing it with z, and we say that z is a plus I or j b, where a and b are real numbers, z belongs to complex numbers, and I or j is a square root of -1. And we call this one real part, and we call this part imaginary part of a complex number. We know that there are multiple ways of representing a complex number. Z is equal to R e to power angle theta, where R is a square root of a square plus b square, and it is always positive or greater or equal than 0. And theta is tangent inverse of b over a, right? Tangent inverse of b over a. We may need a few formulas, like Euler's formula, in order to simplify, but let me write them down in case. If we need to use them, I will tell you again, but let me write them down so it will be a good reminder. We said that in general, any complex number this is the real, this is the imaginary axis, this is A, this is B, this is R, this is theta, right? And then we had this famous formula, e to power I theta is cosine theta plus I sine theta, and we call it Euler's formula. So I think knowing these few things is enough for you in order to be able to handle any type of complex numbers that we have inside this course. Now again, in the revision, when I asked that what is X transpose Y, one of you said that it's a dot product, right? We call it inner product. So let's remind and define it. Given U1 B column vectors in Rn, then the inner product is defined as So the way that we are defining it is this. We represent it with this notation, and it is u1 v1 plus un vn or it's the summation of the ui vi's, and of course I start from 1 to n. Now, because we are also need to define things in the complex form, let's see how the inner product is defined if u and v are in Cn. And if u and v belongs to Cn, then do you know how it's defined?
I think we multiply the real parts together and then the imaginary parts.
So it's conjugate of the first one multiplied by the second one. Where Z conjugate, where if Z is A plus IB, Z with the bar is called Z conjugate is A minus IB. And if it is A minus IB, it will be A plus IB. In other words, the complex term, we just change the sign of the complex term. Now, properties. In general, if u and v belongs to Cn, the first one is if we are interchanging u and v, you understand that the conjugate terms should be switched, so it means that the inner product will be conjugated. However, if u and v belongs to Rn, in other words, if they were real, we knew that maybe in undergraduate you remember that we had real numbers, so we could interchange the inner products. Okay? We could u and v and u, I mean the dot products is the same, but actually if they are complex, they are conjugate of each other. Okay? This is the first. Product, the first property. The second one, if the constant C is a complex number, then C, U, and V is, what can we say about this one? It is C conjugate multiplied by U and V, and it is U C conjugate V. The proof is pretty straightforward. We just expand it. Or we we can write it as this. Right? If we have U, V, W and S belongs to Cn, then U plus V, W plus S is UW plus VW plus UNS plus VNS. If X is a vector in Rn and X is not zero vector, then the inner product of X by itself is always positive. It's always greater than zero. And in order to just simply test your knowledge and do some practical work, example, if U is 2 plus J3, 3 plus J and 4, and V is 4 minus J6, 3 plus J2, find U and V. Let's try to do it. Again, these are all revisions. You might have seen them, but we are just revising it to make sure that you remember everything. How do we do it? It will be the conjugate of the first term multiplied by second term plus then so on. So it will be 2 plus J3 conjugate multiplied by 4 minus J6 plus 3 plus J conjugate multiplied by 3 plus 4 conjugate multiplied by 3 plus J2. This one conjugate is 2 minus J3 multiplied by 4 minus J6. This conjugate is 3 minus J multiplied by 3. 4 conjugate is? A real number's conjugate is itself. So it's 4 multiplied by 3 plus j2. Then we will have 8 minus, this is 12 minus 24j, plus 18 plus 9 minus 3j plus 12 plus 12j. So if you add all these numbers, you have to get 11. No, this should be negative. 11
Minus 19.
minus 12.
19.
12 or 15. Isn't it? 24 plus 12.
In the end, it's not 12.
This is 12, and this one is 12, so it's 24.
Sorry,
Yeah.
in the end, it's not 12G.
It's 8.
8.
Then it will be
17.
5, 17. Right? 2,
That is really 19.
8,
19.
8. Wait, multiply this one. Minus 3 minus this. This will become 5.
5 minus 24 is 19.
Is 19. Okay? And is it minus 18?
Yes.
Um,
'Cause
j by
19
j
squared would be
is minus 1 multiplied by a okay, this minus and minus is plus, minus 18. Okay? Now another question is this. It is known that if A belongs to C n by n. So we denote matrices with a capital letter in this book. B is belonging to C n by P. Then C belonging to C n by P is a multiplication of, can be a multiplication of A by B. Where C I K is the summation of j from 1 to n of A I J B J K. Right? We knew that the multiplication of two matrices is valid if the column of the first one is the same as the row of the second one, right? So we had these conditions that these two should be equal to each other. So here we know that B multiplied by A is not possible. Right? Why? Because P is not equal to M. And let's just simply multiply two matrices to remember how we can do the multiplication. About the exam, in the exam you can have your computers with yourself, but you cannot connect to internet. In other words, if you are using any e-book, you can use it. The reason is that maybe you want to have MATLAB or some program which can calculate these matrix multiplications and so on easier for you. All right? So let's do a very simple numerical example. And the example is this. given A is 2, 3, minus 1, 4, 1, 0, 3, 5, 7, minus 1, 2, 6, and B is 1, 2, 0, 3, 4, 3, minus 2, 1. Find C, which is A multiplied by B. What do we expect to have the results? This one is 3 by 4 and B is 4 by 2. So we are expecting to have C to be 3 by 2. So 3 rows, 2 columns. So C is, so what happens is that this row will be like inner producted by this column. And if you do it, 2 plus 8 plus 0 minus 3 is 7. Then we do it for the second row, multiply by the first column. Then it will be 3 plus 2 plus 0 plus 6, it's 11. Right? We do for the next one, and it's minus 1, 0, 0, 18, which is 17. Then we multiply the first row with the second column, and it will be 8 plus 12 minus 6 minus 1, which is 13. Right? And if you do for the rest, it's 7 and it's minus 12. The last one here I have different number. Minus 1 plus 18, 17, that's it.